Okay, students, let's have a look at this question. It states that a wall 18 meters long, 6 meters high, 20 centimeters thick. Okay, so it has to be constructed using bricks of dimensions 30 centimeters, 15 centimeters, and 10 centimeters. How many bricks will be required? So let us say capital L is the, we take all capital letters for dimensions relating to the wall and small letters for dimensions relating to the brick. So L is 18 meters, and this is for the wall I'm talking about, okay? And then breadth is 6 meters, or width, no, not breadth, I mean the height. Let's erase this height, okay? The height is 6 meters, and thickness or width, we would say, no, you can say, I'll say width, capital W is 20 centimeters. Okay, this is as far as the wall is concerned. Then for the brick, what are the dimensions? I'll use smaller lowercase letters. Small l is the length 30 centimeters. The width is 10 centimeters. It's not mentioned, but we understand 10 by 30 by 15 by 10. So, and then the height will be 15 centimeters. The dimensions are given, isn't it? So it is 30, 15, and 10. Yeah. And here it is 18, 6. So majority of the dimensions are in centimeters. So we will convert this length of the wall into centimeters. 18 into 100 centimeters. Likewise, the height 6 meters is 6 into 100 centimeters. So what happens is this will help us to perform the calculations easily. How many bricks are required? Bricks is having no dimension. It's a count, right? How many? So let n bricks be needed. Let n bricks are needed. Okay. So n bricks are needed to construct the wall, to complete the wall. So that means n into volume of one brick should be equal to volume of the wall, isn't it? It's like the wall. I'm just drawing a rough sketch. This is the wall. The wall has to be covered by bricks like this, right? So I need how many bricks of this dimension? So in other words, n will be volume of the wall divided by volume of the brick, volume of one brick. Now that I have put everything in centimeters, I can directly put the numbers. Volume of the wall is length into breadth into height, and for the brick it's L into small b into small w. Okay, or h, not breadth, it is height, width into height. Okay, L into length into height. Instead of breadth, we have used height here, so we'll go with that. L into W into, okay, L into W into H by L into small w into small h. So N will be, L is what? So L is 18 into 100 into width is 20 into height is 6 into 100. Okay, that is as far as the wall is concerned. We are converting everything to centimeters. And here for the brick, it is 30 into 10 into 15. I mean, it doesn't really matter, 30 into 15 into 10 or 10 into 30, because end of the day, multiplication is commutative. L into P into H, or L into W into H, or H into L into W wouldn't make any difference, isn't it? So this is what we have here. And now, yeah, the rest of it is just calculation. So 18 into, I'm just rewriting it here because I'm going to cancel out things as part of simplification. It's just simplification now. 30 into 10 into 15. 2 zeros, the denominator will cancel out with 100 from the numerator, because 2 zeros from the numerator denominator across numerator denominator are cancelled. Then 3 ones are 3 twos are. Okay. Now it is 5 threes are 15. Then 5 fours are 20. It depends how you calculate it, how you cancel out. Okay, we're going to get the same Answer for n doesn't matter. Then 3 ones are 3 6 are. So we have 6 into 100 into 4 into 2 in the numerator, and the denominator has been reduced to 1. So it's redundant now. So 6 into 4 into 2 into that 100 there. Next to 6. 6 for 24. 3 for 2 is 48. So it will be n is 4,800 bricks. Okay, the count of bricks. This is how it is. Okay. All right. So let's move on to the next question. That is practice I had given you. So the next question relating to that. Let me just move on. Okay. So I'm moving on to page 2. Okay. All right. Now, find the number of revolutions made by a circular wheel um, of area 1.54 meters square in rolling a distance of 88 meters. So there's a wheel. Okay. I don't know the radius of the wheel. I know the area. Okay. There's a circular wheel. What is its area? It is 1.54 meters square. And then I want to find out how many revolutions are made by this wheel when it covers a distance of 88 meters. So wherever, let's say the wheel is at point A, so it's going to, it's going to revolve. The wheel has to move, right? It's not sliding. It's not lateral movement. It's a circular movement, right? So the wheel is going to revolve, and let's say it's going to reach some point, and the distance between that point A and point B, or original and the final point, is 88 meters. In doing so, it's going to revolve, isn't it? How many revolutions have been made by this wheel? We want to know. Firstly, let the radius of the wheel be r. So r is the radius of the wheel. So area of the wheel is given, isn't it? The circular wheel area, pi r square. Pi r square is 1.54. Okay. So r square will be 1.54 divided by pi. Now I can write this as, I can write 1.54 as 154 upon 100, and of course pi is 22 upon 7. I can take this 7 top. So 154 into 7. However you want, you can do it. But don't take pi is 3.14, because if you see 154 is a multiple of 11. Things are going to get cancelled out here. So it's better to go with this. So this is still r square, remember, because area of a circle is, area of a circular structure is, as the circular wheel here is pi r square. Okay. So r square will be 154 into 7 by 100 into 22. Now 14 11s is what? 4, 1, 1, 4 plus 1, 5, 154. So it will be 11 2 times 11, 14 times. Again 2 goes once and 2 goes 7 times. So what is r square? 7 into 7 by 100 is 10 into 10, or 7 by 10 the whole square. So r square is 7 by 10 the whole square, or 0.7 square. In other words, what is r? R is 0.7 meters. Okay. So it's a that is 70 centimeters precisely. If you're going to convert to centimeters, I mean. So it's a wheel with the radius of 70 centimeters. R, not r square, r. R square is 0.7 square. So relating to this, you get r is 0.7 meters. Okay. Or 70 centimeters. Nothing has been mentioned. You can leave it as 0.7 meters. Now the important part is this. How many revolutions are made? See, remember, when the wheel covers one revolution, the distance covered is 2 pi r. 2 pi r corresponds to one revolution. In terms of angular, the angular movement, it is 360 degrees. The angular rotation is 360 degrees removed. But in terms of lateral distance covered, okay, it will be 2 pi r. So 2 pi r, the wheel moving a distance of 2 pi r means one revolution has taken place, or one revolution uh, it relates to a distance covered of 2 pi r laterally. So 2 pi r is nothing but the circumference of the wheel. So, but it's covered how much? 88 meters. So for 2 pi r, it is one revolution. For 88 meters, it is how many revolutions? So it will be 88 into 1 divided by 2 pi r. Same story, you have to substitute for pi 88 to 1. 1 it's okay, it's redundant. 2 into 22 upon 7 into, now that we know r. What is r now? It is 0.7 meters. And the distance is 88 meters, right? So I'll just keep it as 0.7 meters itself, the radius. It's easy for me when they're the same units, right? Why do I have to convert to centimeters? Unless mentioned, no need. So we leave it in the SI units itself. 0.7 ones are 0.7. 0.7 into 10, right? 7. So that will be 88 into 1 by 2 into 22 by 10. Of course, the 10 will go up. So it's just how you calculate now. 2 into 22. 2 into 22 is what? 44. 44 ones are 44 twos are 88. It will be 20. Okay. So it will be 20 uh, revolutions. Now see, I can modify the question. It's not like I'm going to ask you the same thing. The radius can, the distance could be something else. It could be a larger distance or a smaller distance, and the area could be different and so on. No, if they ask you by chance, they ask you the diameter, be very careful. Diameter will be twice of radius, which is 1.4 meters. So you should be prepared for all sorts of questions. And diameter is given, always I told you to extract the radius, because in the formula for area and the formula for uh, this surface area, that is 2 pi r, and circumference, it is always r is involved, not diameter. Okay, with this, let's move on to the next type of problem. Okay, that is, yes, the height of a cylinder is 20 centimeters and the radius of the base is 7 centimeters. Find the volume and the total surface area. The volume. The volume is, just calculate pi r square h for a cylinder. So again here, they've given the height is 20 centimeters, radius is 7. If I give diameter, you should be able to extract the radius. Total surface area, TSA, it is 2 pi r h, that is the LSA or the CSA, okay, plus 2 pi r square. And then when I club the common things, I get h plus r. So what will it be? 2 pi r. 2 pi r is 2 into 22 by 7 into 7. 7 is r into 2 pi r into h plus r. H is 20 plus r is 7. Okay. 7 and 7 will nullify. 2 into 22 into 27. So we can write this as 2 into 11 into 2 into 27. 27 to the 54, 2 is 108. 108 into 11. That will be 8811. Okay, 1188. And this is total surface area. So it will be units of meter square. Sorry, centimeter square. because the other dimensions are in centimeters. So up till here, I hope the explanation has been helpful.